Good afternoon and welcome to this talk, Building RESTful APIs with Symphony Components. Can you hear me properly? Yeah? Okay. So some of you already know me from this morning, but my name is Victoria. I work at Limenius. There we build tailor-made projects for clients. In most of the projects that we build, there is a need for an API, usually because you want to serve the data to your front end or your mobile apps. We have been using Symfony for a long time to build our APIs. And in this talk, I'm going to show you how a few Symfony components will provide you with a lot of help for building these APIs. And also, how, if you decide to use the whole framework, you will have some additional tools that will provide also quite a bit of help. Okay? So I'm going to start with an introduction that where mainly I want to answer a few questions that may arise from the title of the talk. The first of them is, why would I want my API to be RESTful? Maybe for some of you the answer is clear, but perhaps for some others it's not. Maybe some of you can think, well, I've been reading about REST, and I think I can think of a better way of structuring my API. This is a fair thought. You can think that. Also, you can think, I've been reading about REST, and I've been seeing that people fight about a few controversial points quite a lot. So what does it mean? Is RESTful that good if people have to discuss these things so often? I think those are, fair thoughts. But on the other hand, we have two very powerful reasons for deciding to build our API REST. The first of them is that REST makes the most of HTTP, which means that makes the most of the best features of HTTP. And the second of which verbs, status codes, headers. Okay? The second of them is that going with this in this direction means following a common language, having a common language with your colleagues, with the consumers of your API. And in the long run, having a common language is something that always saves you time and a lot of trouble. Okay? But even so, you may think, okay, but is it worth it, really, this trouble of the 3 levels and so on? Well, I think that there is a sane way to approach REST. At least it's the way I follow. You can, of course, do whatever you want, but this is what I do. It has also 3 levels. The first of them is learn the stuff that is commonly accepted, which is most of it. I mean, most of the theory, everybody agrees on it. You just need to learn what is it and do it. Like use nouns for the resources, use HTTP verbs, return meaningful status codes, and so on. So this is the biggest part. Second, you should be aware that there are a few controversial areas. I mean, things that you can read a lot about it, but you will find experts fighting with each other, saying opposite things. And it's quite difficult to decide which one is best. For example, things like, do I have to return the created or updated resource? Can I have different URIs for different representations? For example, this second one, if you look out there, you will find Lucas Smith, which is the author of FOSS REST bundle, saying that you shouldn't, because this goes against the concept of REST. Okay? But if you keep looking, you will find a guy who is the author of the concept, and he says, well, I never said that you should use content negotiation all the time. And on his website, he's actually using 2 different URIs for 2 different representations. So what to do? So then we arrive to the 3rd level, or the 3rd step. In these cases, you need to choose a side. I mean, whatever makes more sense for you, for your colleague, or however you prefer to decide. Deciding is not the most important part. The important part is once you have decided about this, you need to stick to that. I mean, you need to be very consistent when building your API following these decisions, okay? So to summarize all this, building APIs has a lot to do with being civilized and consistent, okay? It's not so much becoming something like this is more like being calm and consistent with your decisions, right? Second question, why Symfony and REST? Why are we putting these two words together? There is a reason behind. REST, as we have said, is a very strict definition, is sometimes a battlefield, but it's a way to make the most of HTTP. On the other hand, Symfony was also created thinking a lot of making the most of HTTP, around the HTTP protocol, okay? So in other words, we can say that REST loves HTTP and Symfony as well. That's why they fit well together. Our third question is why Symphony Components? Why not just Symfony? Why components? As some of you may know, Symfony is two things, a full stack framework and also a set of independent components, okay? Those components are simply decoupled, reusable libraries that you can use somewhere else, in your code, wherever, without the framework. Actually, many popular PHP projects have been using Symfony components in the last years. These are some of the components, and for example, we have Doctrine that uses console and Yelm, Propel, with also using class loader, Silex that uses a lot of them, Drupal that since version 8 I think is using some of them as well, Laravel. So these components have been helping in the last years to bring some standardization to the PHP community. In this talk, we are going to see in detail 5 components, these 5. HTTP Foundation, Serializer, Validator, Form, and Guard. Why these 5? Because are the 5 that are going to help you building your APIs. The knowledge that you are going to get from these components, you can apply it later when working with the whole framework, when working with these components in a different framework, or even when using them in your own code. Even you could try to create your own small framework, if you want, using those components. Actually, that's a pretty cool exercise. If you haven't done it, I tried it, and it's really interesting. In this link, you can follow and see how to do this, and you learn a lot about how a framework is built and what things do you need. In this repository, what I did was to put the 5 components that we are going to see together, okay? There you have the full code of the examples that I'm going to show you, because of course I'm only going to point out the main things, but if you want to really see the whole thing, is there. Okay, let's see those components, starting with the HTTP Foundation that is going to be the foundation of our API. This component is going to provide us with object-oriented layer for the HTTP specification. Okay, how does it work? As you know, in PHP, the request is represented by some global variables, and the response is generated by some functions. Okay, so this component is going to replace those global variables and functions by 2 very nice objects, request and response. Okay, how to do this? If we want to create a request, we will use this create from globals method that simply is going to create it from those global variables from PHP. This is the same as this, okay? That's all. With that, we have a request object. What about the response? For creating the response, we will pass 3 arguments, the content, the status code, and some headers. That's all we need to do. So let's see how to create a first endpoint with what we already know. The requirement is very simple. We just want to receive a 201 status code when calling there. All right, we create our request, decode the content. We do whatever we want to do with the data in the middle, and then we are going to create a response, okay? Putting some content in there, our status code, and 2 headers in this case. It's the content type and the location. With that, we already have an endpoint working. If you want, you can use a shortcut. Instead of response, you can use JSON response that basically is setting the content type header, so you don't have to write that line. It's a small shortcut, and also encodes to JSON. Okay, what about PSR7? PSR7 is a standard that was released, I think, a year ago, that is very related to this. As we have said, the HTTP Foundation component has brought some standardization to the community, but this standard is a step further in that direction, okay? So I guess, although I cannot know yet, that Symfony 4 will embrace this standard, but until then you can use the Symfony bridge to make your objects compatible with this standard, okay? It's very simple. You use this bridge, and then you can make your request and your response compatible with this standard, okay? If following standards is not a good enough reason for you, for example, you may want to do this because you may want to use some middlewares. There are a lot of middlewares out there implementing several functionalities that you would be able to use if you are following this standard, okay? Just wanted to point this out because this is, of course, newer than the HTTP Foundation component. Let's go with the second, the serializer. The serializer is going to be one of our best friends because it deals with something really important. It allows us, or helps us, to create representations from our objects and the other way around, which is something really, really important when building your APIs. Okay, so imagine that you want to do this manually, okay? If you want to do this serialization and deserialization manually, you could write something like this. One line for each property to turn your request, the request into our object, okay? And the other way around, one line per property to create a response from our object. This looks quite boring and tedious to write, and it is. And imagine if you have 50 properties instead of 3. So the serializer is going to save a lot of work here. Let's see. If you want to convert our object into a JSON response, instead of this, you only need to say, hey, serializer, just serialize my object into a JSON. That's all. It's only one line, okay? And in the other direction, very similar. You want to convert your JSON content into an object, and then you just say, serializer, please deserialize this content, put it in our recipe object. It will come in a JSON form, okay? Only one line. This is how the schema of the serializer component looks. It looks a bit complicated maybe at the beginning, but it's not. It's simply transforming objects into JSONs. You see that there is something in the middle. This is because they split the process in two. One part that deals with the transformations between arrays and JSON, for example. Those are the encoders and decoders. And the other part that deals with the transformations between arrays and objects. Those are the normalizers. Usually the heavy work is done here by the normalizers, okay? Before using this, you will have to do some setup in order to tell which encoders are you going to use and which normalizers. Here, for example, we are saying we are using the XML encoder and JSON encoder, and we are using the object normalizer. The object normalizer is like the most powerful one, but you have other normalizers out there. You can check that in this link. So instead of going further with things that you can check there, what I really want to point out is why is this so helpful? The serializer is so helpful because when building an API, you really realize that the representations that you want to show are not the same thing that you have in your database, of course. For example, they are usually quite different. Imagine that you have this user in your database, okay? If you want to create a representation from it, you may want to, for example, change the name of this property. Instead of calling it name, you may want to call it username, for example. Perhaps, or very likely, you won't want to show the password, even if it's encrypted. Maybe you want to show some properties when they are asking for only one user, but not when they are asking for a list. Perhaps you want to prepend some prefix to some of these properties, or to show some of them in one version of the API and not in another version. Or maybe you have some things like this, like nested, and you want to turn them into regular properties. So all these things, the serializer is going to help with that, okay? To really make easy to create the exact representation that you need. For example, with things like this, it comes with two annotations. One of them is max depth. Max depth is saying, okay, when you serialize, just stop at the second level. What does it mean? Imagine that you have an object, another object related to it, another related to it, another related to it, and you don't want to serialize all of it. You just want to stop, I don't know, at the second level or third level. So you can do that with this. This is very useful when you are working with big trees or when you have circular references. Another annotation are the groups. The groups are going to allow you to serialize different sets of properties. Okay, let's see this with an example. Imagine that we want to create an endpoint, a get, that returns the recipes, but only with these two properties, name and servings. Okay, name and servings. For doing that, we are going to use this groups annotation, and all the properties are going to have the group detail, but only the ones that we want have the group overview. So simply like this, when we serialize, when we call the serializer, we are going to tell him which group do you want to serialize. Okay, in this case, we only want the overview group. And like that, we will be meeting our requirements. Okay, it will be serializing only those properties. Another thing that you will have to do quite often is to create your custom normalizers. Okay? Remember that this is the part that deals between the object and the arrays. For example, let's see this. Imagine that you want to add a prefix to some property. In that case, you will have to write something similar to this name converter interface that has a normalized method and a denormalized method. Okay? In the normalized method, in the direction of serializing, you will be adding this prefix. And in the opposite direction, you will be removing it. So this is very simple, but as you can imagine, with this, you can do much more complex things. Okay, okay, that was the serializer. Let's move on the validator. The validator is going to enforce sanity. What does it mean? Of course, we don't want that any kind of data arrives to our database. We want this to be validated. We cannot leave that work to the database. It should be done before that. So that is going to be the work of the job of the validator. Let's see how it works. This is a very simple example in which we are going to validate a string, just a string. But it's to show you the parts that you have here. You have two parts. One are the constraints, which are basically the rule formulations. And the other one are the validators, that is where the logic is. So if at some point you need to write your custom constraints and validators, the logic is going to be there, the validator. Okay, this is very simple, it's only a string, but what happens if we want to validate an object, so something more complex? Then the validator needs to know which constraints apply to each property, all right? And you can do that, for example, with annotations as well. Here we have two, greater than or equal, and not blank. You can write this with annotations, but also with YML, XML, and so on. The validator comes with 50 constraints, or more or less, already there, and of course you can write your own. Okay. Apart from validating, the other very important thing to do once you have validated is to return meaningful errors. In an API, this is extremely important because otherwise the consumers of your API may be not very happy. So you really need to take care of that part. That part could be used for a different talk because it's quite extensive, but if you are interested in knowing more about this, I recommend this resource. This is one of those NP courses that are very good. They have several about building RESTful APIs with Symfony. So and the second of them is only about errors. So it's worth a look. Our fourth component, form. Now you may wonder, why are we talking about forms here if there are no forms in an API? The reason, well, there are two reasons. First of all, that dealing with the data that comes from to your API is similar to dealing with the data that comes through a form. Okay, there is some similarity there. And also that if you are in a project that where you have an API and also forms somewhere else, you will be able to reuse some of that code. So it's usually a good idea to use this component as well. This component is going to provide a deserializer and validation, okay? A powerful deserializer, actually, and validation. So that's why we normally use it when building APIs as well. To see it, let's build a put endpoint, okay? This put endpoint needs to return a 200 status code, and let's see how it looks. We have our data, decoded from the content of the request, and then we will build our form, and bind the data to it. Okay, with that you already have it, and you can check if the form is valid. Okay, this is really straightforward. Of course, after that, as we mentioned, you should be returning some errors if the form is not validating, and so on. These things, you can see them, because you can see them, this is not so straightforward, in the repository that I mentioned at the beginning, okay? Because, for example, serializing the errors that come from the form needs a bit of work, okay? All right. Now is a good time to ask a couple of questions, because I didn't want to go into the detail of all the REST theory, since I'm sure that most of you already know it, but from time to time, there are a couple of questions that is worth to review. This one is post to create and put to update. Okay, that we can say that is the common knowledge, but it's not true. Although if you follow that rule, you will be kind of okay, more or less okay. But the whole truth is this. The whole truth is that you have to use put if the operation is idempotent, which means that if you perform it several times, it will have the same result than performing it only one time. And second, the URI needs to be the address of the resource. If those two things are true, then it's a put. Otherwise, it's a post. That's it. This is not a controversial point. This is like this, but somehow it's a bit difficult to remember. Another question that we can have is, do I have to return the resource when we update or create one? Well, many say that we don't have to, but some clients will expect it. So again, this thing is up to you. It depends on who are you developing your API for and these kind of things. You have to choose here. All right, our last component is guard. Guard is going to help us with authentication. In Symfony, we have a bigger and more complex component that is security, okay? Security is very powerful, but is also a bit complex. And they wanted to make something simpler, for simpler cases, so they came up with this guard. This guard component is something so simple that the only thing you need to do is to implement one interface, guard authentication interface, which consists in these 7 methods that are very thin methods, very understandable. Implementing this, you already will be taking profit of guard, okay? This is not saving you from implementing later authentication strategy, like JSON tokens or auth or whatever. This is only like preparing you for that, okay? The other work needs to be done as well. Okay, at this point, when I put my 5 components together, you have already felt that you need things that you usually have in a framework, routine, event dispatcher, kernel, and so on. So at this point, it's worth to ask yourself, and what do I have if I use the whole framework? And that's what we are going to see now. Which additional things do we have with the whole framework. Okay, using the whole framework. The whole framework uses all these components and some others. A component, as you know, is a library that can be used somewhere else, but we also have in Symfony bundles. Bundles are tied to the framework, okay? And usually it's very common to have a library, which is the one that has the functionality, and the bundle, which is configuring it, integrating it with the framework. So what we are going to see are a few of these bundles. Of course, useful for building APIs. All right, the first of them is this JMS serializer bundle. This is an alternative to the serializer that we have already seen. I cannot tell you which one is better, because both of them are very good tools, but they are slightly different. For example, this one has lots of annotations that make very straightforward to do a lot of different common things. Maybe it's easier to set up and start working with it, while the serializer component is more about writing your own normalizers, which is something it's a bit complex, but it's also very flexible. So it depends on what you have to do, but both of them worth a try, okay? Some cool things that this one has are, for example, these 3 exclusion strategies. Apart from the groups that we already know what's about, we have this exclude annotation that allows you to exclude the properties that you don't want to get serialized. Versions to say which properties go in one version and another version of the API. It has virtual props. It has events that give you extra flexibility, and so on. So it is really worth a try. The next bundle is the FOSS-REST bundle. The FOSS-REST bundle is not one tool. It's like a toolbox, like a set of tools, okay? That all of them are, or most of them are very helpful. I wrote here a few of them, but there are many others. Generally speaking, it will be quite useful when you have different want to have different representations of your in your API of your resources. Okay, that's when you have something like that, it's a good idea to try this. It has many things like a body request decoder, a parameter validator and converter. It has a listener that performs content negotiation, deciding which format is the adequate, and so on. So it's a set of tools that if you have never seen it, maybe you don't miss it, but once you know it, it's quite, you get quite attached to those things. Okay, next bundle. This bundle is going to allow us to have JSON Web Token authentication. Okay, JSON Web Token. The bundle is based on these 2 libraries. The second one of them, I think we have the author right here, and he's speaking tomorrow, so don't miss that. And if you don't know what this is about, the concept is kind of easy. It's a simple way of authenticating. You will be sending your credentials to an endpoint that you have configured in your configuration, okay? And with that, you will receive a token, okay? Something like that. And from that point, with that token, you will be able to make your requests being authenticated. So that's it, okay? So it provides a simple way of authentication. There are other ways, of course, like OAuth, for example. But in my experience, for using OAuth, you really need to have a good reason, because it's much more complex. And many times with this is more than enough, okay? Next bundle is going to allow us to reach level 3. What is level 3 about? Level 3 is about returning links that allow the consumer of your API to discover other things from your API, okay? So it would be something like this. Instead of returning only the recipe, we will return as well this link. That's level 3, okay? Simplifying a bit, but yeah. How is that? We will have an annotation that is going to generate the routes for us, which is very helpful, okay? And just with that, you have level 3. So now is the question, do we have to reach level 3? Theoretically, if you don't do it, your API is not RESTful. In reality, many APIs out there don't do it. So again, this is something that depends on you, on who are you developing your API for, and so on. So if you want to do it with this bundle, it's easier. And the last bundle I want to mention is Limenius API bundle for documentation. Okay, it's going to help you keeping your documentation updated. While you are coding, you will be writing some annotations, and then from them is going to be generated the documentation. Okay, so it's good to write the documentation, as you know, while you are coding, because otherwise later is much more tiring, and sometimes you don't do it. So it's easy to keep the documentation updated with this. It looks, the annotations look like this. There you write all the documentation that you need, and then it generates something like this. Okay, this is the documentation. This comes from this is got by introspection from the code. Okay, and that's it. So all these tools have been there already for some time. What I want to show you now are a couple of things that are quite new, because of course new things appear, and it's good to know them. This project, API platform, is becoming quite popular. It's built on top of the full Symfony framework, and with it you can build an API in 40 seconds. I will try to show you later if it works. It has a lot of cool tools, like, I don't know, Docker integration. You can use it with FOSS user, JSON web tokens, Behat, PHP unit with Postman. I mean, it's really very complete, and it's worth a try. I have tried, and you only need to type a few commands to have actually an API working with Swagger interface included. I don't know if you have seen it, but I'm going to try to show you this. If it doesn't work, well, I have a video as well, but let me see. I think we have to do just... Okay, we install it with Composer, waiting for the internet. This doesn't count in the 40 seconds, of course. Okay, I have to type this because I don't know why the default is... Yeah. Okay. All right, and now the database. No, I have to enter here, of course. Database and the schema. Let's see if this worked. Why? That's all. Ah, true. Very true. Okay, here we go. This is this Swagger user interface that is very cool. It's going to allow us already to test our endpoints. So here we have the get, for example. If we try, we won't receive anything, of course, because we don't have anything. Only a 200 response, okay? That's it. If we want to post something, we have this as an example. We put here, hey. Okay. Probably if we now get what we have, it will be there. Yeah, here it is. So this is quite complete for the time that it took. Of course, it has been done with a default entity, but you can do something similar very quick. All right? OK, so that was API platform. OK. So what else do we have? Which apparently my head is too small for this. Next November is going to be released Symfony 4. And Symfony 4, well, if you have been in my previous talk, you already know, but it's moving towards making configuration much more faster, to allow you to spend very little time in configuring things. Okay, so it's also moving towards the idea behind is to allow you to make for you very simple to have a project with few dependencies, and also simple to have a project with lots of dependencies. Because they want to make it very easy to install, uninstall, configure, and configure. So it should be, and it will be very easy to have an API project that only has the things that you need for an API, and not all the other stuff that you don't need. So this is the idea of Symfony 4, to really let you have the dependencies that you need exactly, and not anything else. So Fabien Potencier, like I think it was 2 weeks ago, he posted a screencast creating with Symfony Flex an API platform, an API project. So you will have a Symfony project with the API platform plus whatever else you want to have there. And it took for him only a couple of minutes to have it. So if you have not watched it, have a look, because it's actually quite, I don't know, exciting. We are waiting to see how it actually works. Okay? So that was it. Let's try to remark a few things that is important to remember from this talk. The first of them is whatever choices you make while building your API, you really need to be consistent with them, and you should be taking profit of using a common language. Okay? REST and the Symphony components will make that easy. Okay? They fit very well together. A few components provide a lot, and if you want more help, you have the option of using the whole framework. And finally, Symfony 4 and Symfony Flex are moving towards making all this very quick to configure, and it will be very straightforward to have a project with your API plus whatever else you want to add. However, this does not mean that we don't need to understand all that is below that. Of course, we have to. And simply remember that building APIs is more about being cool, calm, and really, really consistent. That's it. Thank you. Questions? Yeah.
Should we use all HTTP verbs, like patch or headers, or should we stick to the 4 basic?
If you need the others, you should use them, but I normally, patch, you will need it at some point, but normally with the basic ones that you know is enough. Yeah. Something else? Okay.
Which tools do you use for testing your APIs? You are building normally a lot of APIs, or some APIs you need us to test them. Which tools do you use?
We use Gazelle and PHP Unit, which is very simple, but it works, and enough, more than enough. Something else? Yeah.
Struggle a lot with strict types, deserialization on objects, and validation. You have some kind of advices here, or?
No magic advice there. Sorry. I mean, it depends on the concrete problem. I cannot tell you. Yeah. Something else? Thank you then. Thanks.